Today our tutorial is about abstract classes, the first part. The second part will be on interfaces. We will first introduce the abstraction concept in Java, then we can move to the implementation. So what is abstraction and why it's needed here? Abstraction is a process where you hide details of implementation and you only show functionality to the user. In other words, what to do, but not how to do it. How to do it, you decide. Or how to do it, she decides. Maybe she's going to do it in a different way. But what to do, I want you all to do this task. Okay? Let's say I want you all to go and get a copy of this. Whether you photocopy it, you make a scanning, whatever. Everyone is going to do it its own way. Or go to this destination. You can use a different route from here. But the task is to go to another destination. Abstract classes in Java cannot be instantiated. And if you have an abstract class, you cannot create a class from it. If you have an abstract class, you cannot create a class from it. Why? Because it's abstract. It tells you what to do, not how to do it. So how can I use it? How to use it is another story that you can subclass it. You can create a subclass of an abstract class, and from that subclass, you instantiate. You implement the abstract things in the abstract class in the subclass. In the abstract class, you will be having mostly abstract methods. What is abstract methods? Method with no implementation. So why we need it? Okay, I can make an abstract class with 3 methods. 2 are abstract, not implemented, and 1 is implemented. The unimplemented methods must be implemented in all subclasses in their own way. This way, I enforce you all, let us say you are all subclasses here, you all are going to implement those abstract methods in your subclass. So did we kind of like enforce uniformed implementation? So now if you are a subclass of one abstract class, then we know that you all implement these 2 methods. Does that make sense? Tamam. How you implement it is another story. Now we're talking about design. So you use an abstract class when you want to define a template to guarantee that all subclasses in a hierarchy will have certain common methods. Crystal clear? Is this clear? That I know all subclasses will have those methods implemented their own way. Tamam. Next. An abstract class can have both abstract and regular methods. Let us say this is an abstract class, public abstract class. Then the name of the class, some class, as you see here. Okay. So here, the name is what? Some class. One method is what here, as you see? Abstract. Another method is not. So if you are a subclass of this class, you inherit this method, method 2. You don't have to implement it. You can override it. But you must implement which method? Method 1. You cannot actually be a subclass of an abstract class unless you implement all the abstract methods. So all the subclasses of this class will definitely implement what? Which method? Method 1. But all of them inherit what? Method 2. So some methods can be abstract, some methods are not. If you have methods with mostly going to be done the same way for all subclasses, then no need to make it abstract. They can override if they want. But abstract methods must be entirely implemented by subclasses. So now the motivation, we guarantee all subclasses will have certain methods. Is this clear to you? So is it enforcing common design now? All subclasses will be implementing the same methods, right? There are 2 ways how to achieve abstraction in Java. First way is abstract classes, and we say 0 to 100%. Why we say 0 to 100%? Because in an abstract class, not all methods are necessarily going to be abstract. Yani, let us say you have an abstract class with 5 methods, 3 are abstract, but 2 are not. So let us say 60% is abstract, but 40% is uniform, implemented. But with interfaces, and although this is not accurate in the latest versions of Java, all the methods will be abstract. Go ahead, what's your question? Okay, here this class is what? Abstract. Okay, then abstract class can have methods that are either what? Abstract or non-abstract. If you are a subclass of this class, what are you going to do? You must implement one method, which is what? Why? Because it's abstract. That's it. So all subclasses of this are going to implement method 1, yes or no? They can add their own attributes and their own method things, but all of them now, we know they're going to implement which one method? Method 1. So if you tell me you are a subclass of this class, then I know you definitely implemented what? Method 1. Method 2, you don't have to. You can inherit, right? Extend. Let's see the next one here. This is an employee. How do you know employee is an abstract class, ya banat? Look at it. Is it italics? In any class diagram, when you see it in italics, then you know it's what? And employee is a class. Then this is abstract class. Tamam. Year-to-date earnings, this is a attribute. All employees, they make payments from the beginning of the year. But look at this method. What is it? Is it abstract? Why? It's italics. Tamam. So from the class diagram, you can tell if the method is what? Abstract or not. Now, this class is abstract. The employee class is abstract. Can you create an object of employee? No. However, you can create a subclass of what? All subclasses of the employee class must implement which method, ya banat? Compute pay. For example, full-time employee has a salary, صح? But part-time employee, see, we added what? Because this okay, maybe he worked only for 10 hours, or 50, or 100, right? But this guy has a weekly what? Or monthly salary, right? So the way we pay is different. But both of them implement it in their own details, صح ولا لا? Right. So for a part-time employee, this will be, compute pay will be implemented in a different way from full-time employee. Abstract class is employee, one abstract method. All subclasses of the employee abstract class are guaranteed to implement which method now? Compute pay. Can you add your own data attributes, your own elements? Yes. Okay, good, excellent. Next. So abstraction, an abstract class must be declared what? With the abstract keyword. You can have both abstract or what? Can you create an object from abstract class? So it cannot be instantiated. You can have final methods. When a method is final, what does that mean, ya banat? Cannot be overridden. When a class is final, it cannot be subclass. Anything final is like a constant. If it's a value, you cannot change it. If it's a method, you cannot override. If it's a class, you cannot subclass. Tamam. Good. Okay, you can have constructors and all these things. Now look at this important example. This is the core example that usually we use when we teach these subjects. Shape. What is shape here, ya banat? Abstract. And it has two methods. What are they? Get name. Both are abstract. Can you do this code shape equal new shape? Why? Okay, so we cannot create this one. So what's the, any subclass of the shape, what it needs to do? But I still can add radius or side or width and length, right? But what do I need to implement? Get area and get name. Maybe, if you see get name, not necessarily needed to be abstract, you can implement it. And I'll show you both. Look at this one. Public class what now? Rectangle, right. Extends what? The moment you say extends shape, then the compiler will ask you to do what? Implement the abstract methods in the super class. Otherwise, it's not going to work. Can I add width and height? Do whatever. do all the details for your subclass. Tamam? But what I need you to do, remember, we said, I tell you what to do, not how to do it. Calculate area of a rectangle is different from a triangle, is different from a circle, is different for 2D and 3D shapes. So now, for the rectangle, we have width and what? Height. Get area. What do you see here before the method get area? Do you see override? Good. Override is good here. It tells you that this method is overridden from, so you know it's not your own method, it's overridden from somewhere. طيب, is it implemented here? You calculate what? And return it. Is it clear here? طيب, get name. What's the name of this guy? So what does it do? Return what? Rectangle, that's it. So here we have a class called shape, and then we have what? A subclass implemented. Can you create now a new rectangle? Yes. Because rectangle is a concrete class. You can instantiate it and you can create objects from a rectangle. طيب. The question is, and now it should be very clear with this example. Circle. What is a circle? Is it a shape? What attributes you need for a circle? Radius only, right? Can you make get area of a circle, right? Can you make get name also? So in order to be a subclass of shape, you need to extend what? Shape. Extend shape first. Once you extend shape, you are a subclass of shape, right? However, your superclass has abstract methods only, right? So you must implement both of them. So for a circle, do you see the get area now? And is there any question on get area? Straightforward, right? And get name, what does it return? String. So now, can you create a circle and a rectangle? Do you guarantee that both of them have get area and get name? Why? Because they are a subclass of an abstract class. They cannot be a subclass of shape unless they have already implemented what? The abstract methods. So now, whenever you see a subclass of shape, you know that there are two methods in that subclass, yes or no? What are the methods? Okay, so now any subclass of shape, I know it has those two methods in it, right? So did we enforce common design here? Did we enforce them to use the same methods? But each one has implemented it in a different way. Tamam, excellent. Can you now create an array of shapes? Yes. Can you create an array list of shapes? Tamam. We studied polymorphism, and now we know circle and rectangle classes, each with get area and get name, right? طيب. Look at this code. Shapes, shapes. But you cannot say new shape. You can say new what? Any subclass of what? See here, new circle, new rectangle, new square, new whatever. Okay, good. طيب. Double area is equal to sum. For shape S of in shapes, sum plus equal get area. All shapes are guaranteed to have what? Get area, right? You don't have to double check if they implemented, if the circle or rectangle implemented that. And when you call get area for S, it will be called for first time, it will be called for which object? Second time, for which object? Rectangle. And does that make sense to you? Can I add a square now? And it's a subclass of what? Shape. Can I add a square to the shapes array? Do I have to change the code in the for loop? No need to change the for loop at all, right? Because the square will be a shape, and definitely it would what? It would have what? Get area and get name methods. Does that mean if you come back to me now and say I need triangle, what do you need? You need width and base and height, right? Get area, you know how to do it, right? Get name is going to be what? Triangle, that's it. Is it a shape? Can you add it? So even you don't have to touch this code, صح? Because any subclass of shape is guaranteed to have those two methods. Okay? Class modifier, you all know public. Abstract, now you know it. Abstract is a class that you cannot instantiate. Some methods are abstract and some are not. Final, if it's a class, it cannot be subclass. If it's a method, it cannot be what? overridden. Look at this, another example. Animal, is it abstract? How many methods are there? One is abstract, the other is what? Animal sound is abstract, right? Sleep is no. Type. Now, if you subclass animal, which method you must implement? The animal sound. And the other one, sleep. But you have a choice. You still have a choice to override, right? Yani if you want for the dog to show it in a different way, you have a choice. You can override. But for the first one, do you have a choice? So, okay, for the second one, you can override. Tamam? Okay, so now look. Class cat extends what? Any question? This one, animal sound. The cat says meow meow. Any question? So now we create a new cat, right? When you call animal sound, which method is going to be called? The method of the subclass, the concrete. When you call sleep, which one is going to be called? Do you have a sleep in the cat? Do you have a sleep in the cat? So where is it? In the super class, right? Unless you override. If you override, what's going to happen? It will call it from the overriding. This is another example, and look here carefully for this example because we get okay. No, not this one. Public abstract class shape. This is a different from the previous one. We have one method, which is what? Draw. All shapes are drawable, right? Yes or no? So now, if you have a rectangle, you must implement it. If you have a circle, you must implement which method? And rectangle, if you have any shape. So now we know any subclass of shape must implement which method? How they implement it, it's their problem or your problem. Okay? Tamam. But we know all of them have what? Okay. Here, can you say shape new circle? Yes, you can. Okay. Downcasting and upcasting. Okay. So when you say new, whatever you say new. Okay. So the circle now has a method that is what? Definitely has a method called what? Draw. The rectangle definitely has a method called what? Tamam. Excellent. Now look at this example and we will start from here to do today's hands-on example. Shape. Okay, is it abstract? Look at the, is it? Type two methods in it. What? Are they both abstract? What about to string? I said maybe to string is not needed. We can reuse it. You can override it in the subclasses. And maybe from the previous examples and previous tutorials and problem-solving sessions, you have seen me reusing the code from Tayyip. But now, this example is not straightforward like the ones you saw. It has two layers of abstractions. Let us see now. First, all shapes have get area, yes or no? All shapes have get name, right? And you can print anything in Java. Fine. What about 3D shapes? Wait, what about 3D shapes? They have what? In addition to area, they have what? Volume. Yes or no? Hajm, right? Sub 2D shapes, they have one extra thing. Perimeter. اللي هو ايش بالعربي؟ محيط. Hey, but look at this one. I want you to understand this. Expect in real Java exams, you see something like this and you implement. This is your exam, maybe. Okay, get perimeter. But is 2D shape abstract? But 2D shape is a subclass of shape, yes or no? And 3D shape is a subclass of shape, right? Before going here, ya banat, to the circle and one. If 2D shape extends shape, then all the methods in shape are what? Available where? Are not necessarily implementable. This is a good question now. Why? I will explain this. But now, do you all agree that get volume is a characteristic only of what? 3D shapes. And get area is a characteristic of what? So can we put both of them in shape? Get perimeter and get volume? But this will be what? Useless for 2D shapes, right? So now, that's why I added two layers. Now, is 2D shape abstract? طيب. But in 2D shapes, I am not going to implement what? Get name and what? Is it allowed to be a subclass of an abstract class without implementing the abstract method of the abstract class? Yes, it is allowed in one case, which is what? The class itself is still what? Yani this is an inheritance. 2D shape inherits everything in what? But if your class is not abstract, is square abstract here? Is circle abstract? So now tell me about a square. Square must implement all the abstract methods in what? In all the parents of the hierarchy, yes or no? So shape is not an abstract class. Is it a subclass of 2D shape? Yes. And 2D shape is a subclass of what? Shape. Then a square must implement all the abstract methods in all the abstract super classes. Only the abstract super classes. Yani for get name, it's a choice. For get name, ya banat, it's a choice. You can override, huh? But for get name, sorry, for toString, I'm sorry. For toString, it's a choice. But get name, is it abstract? Then it must be implemented where? In square. Get area, is it abstract? But it's inherited from which class? Shape. What about get perimeter? It's inherited from where? 2D shape. Now, so, okay, طيب. Then, you know what to do now, صح? Your square has one side, right? To get area, you know how to get area. To get perimeter, you know how to get perimeter. And look at circle. Circle. Is it a subclass of 2D shape? Yeah. Is it a subclass of shape? So all the abstract methods and all the superclasses must be what? Implemented. Which are what? Excellent. طيب. Is circle a 2D shape? Yes. Is circle a shape? Yes. Right? Okay. Is a square a circle? No. Circle is? Yes. Because it's a subclass of it. But square is not a circle. Now look at the other side, the right side here. What's the new abstract method in the 3D shape? Get volume. Is it clear to you that this method is abstract? And now, for any subclass of 3D shape, which three methods must be implemented? Get volume from which class? From 3D shape. And get name and... So whatever abstract methods in the class hierarchy, you must implement the subclass. Does that make sense? Is it clear why I isolated them into 2D shape and 3D shape? Why? Because what? Because there are some difference here. The common things were left where? In the shape. But the things that are what? Different. We put them in a second layer, right? All of them are shapes. But if you're, okay, all of them are shapes, but cylinder is a 3D shape. So if it's a 3D shape, then you can call which method also? Okay, tamam, excellent. So now I will create a, aywa, go ahead. Here, خلاص, they are by the, hey. Which one? Which one? Here? It's already from here, inherited. They don't have to show it to you. All of them are available. The methods in the shape, the abstract methods in the shape, already are available in any subclass, because 2D shape, is it a subclass of shape? But why 2D shape is allowed not to implement the get area or get name? Because if you are a subclass of an abstract class, you have a choice not to implement the abstract methods only if what? Only if you are an abstract class. Yani 2D shape is an abstract class. It has its own new methods, which is what? Get perimeter, صح? But does it still have abstract methods from its superclass? Yes. What are they? So if you are a subclass of 2D shape, yes, you must implement how many abstract methods? 3. Because 2D shapes inherits 2 from where? From the shape. 3D shape inherits 2 from where? And because they are abstract classes, 3D shape and 2D shape, they have a choice not to implement it. But in a concrete class like cylinder or circle, you must implement all the abstract methods in the abstract classes hierarchy. Okay, let's go and see some code now. Here's the code. Look at this, ya banat. Public class shape. Any question? Public string get name. Abstract or not? Abstract. Public abstract double get area, right? To string, is it clear? Shape and what? Get name, and get name will be called from the subclass area. Okay? Is this enough? Is this the common thing we did in our hierarchy? Type. I will make a square now. I want you to see a square. Or we have a square, let us make a triangle. Does that make sense, ya banat? Yalla, I need. Okay, wait, before we go. We have 2D shape. What is extra in 2D shape? Look at the code. Public what? First word. Abstract. So if you are abstract, no problem. You have a choice not to implement. You can implement some, but you have a choice. Because we cannot create a 2D shape. Because 2D shape itself is what? Extends what now? So which methods are abstract here? Get name and what? Tamam. Okay, excellent. So now, and here we have, oh, this is overridden, sah? So what I used here in line 6, return what? No. Return super. Super to string. So it will get all the to string method from the shape plus add what to it? Okay, that's it now. We will add the perimeter, sah? So any subclass of the 2D shape will print what, ya banat? Will print the shape name and what? But if it's a 2D shape, it will also print what? In addition to the thing inherited from the superclass, it will print also what? طيب. Let us make a triangle, make a long story short. Tamam. New class. Triangle, we know what triangle. Actually, I cannot make a triangle. I don't know how to calculate it's what. It's the perimeter. We must have it in a different way. Let us see a square now. This is a square. Look at the code here. Public class square extends what? If it extends 2D shape, then it also extends what? Shape. What do you need extra attribute for a square, ya banat? Only one thing you need for a square, which is what? In the constructor, do you see it? So, get side or set side, any question on them? طيب. And this one inherited from which one? Get perimeter. This is how we calculate the perimeter of a... Okay, this one inherited from which one? Shape. And this one? Shape. And this is a 3 level of what? It's 3 levels of overriding. The shape has a toString method, right? That returns the name and the area. The 2D shape has a toString method that overrides the toString and add to them what? Perimeter. And now here, since this is a square, what is the extra thing in the square? So if it's a circle, tell me what you add here. Perimeter is going to be from the 2D shape. Area and name will be from shape. Does that make sense? You see the levels of hierarchy. Tamam. طيب. I will go and make a... Now, what about circle? I think now circle is clear. Extends what? Okay, what is the parameter that or attribute you need in radius only, right? Is there any question on the constructor of the circle? Okay, but since you are a subclass of 2D shape and 2D shape is abstract, you must implement all the abstract classes of the 2D shape and it's all super abstract classes. Set radius, get radius, any question here? What about get perimeter? We know, oh, this is a new implementation, صح? Okay, now we know all our subclasses have get perimeter, صح? But each one implemented in a different way, depending on what? If it's a square, they have one way. If it's a rectangle, they have another way. If it's a circle, or. Get name. Okay, get name, now we return what? Get area. So now, you remember this. Now, in addition to the toString that inherited from the 2D shape, which was inherited from the shape, now I use all of them plus what? radius. This is called reuse. Excellent example. طيب, do I need to explain the rectangle or do it ourselves? I'll delete it يا بنات from here. I'll delete the rectangle and do it ourselves. تمام. So let us create a rectangle now. Okay, class rectangle. تمام. Okay, first thing what to do? Extends what? Go ahead, tell me. Extends what? 2D shape. Let me see how I wrote it. 2D shape. Tamam, I think capital S, right? 2D shape. The moment you do this, what they tell you now? Oh, you must implement what? Type, don't worry, I will implement it. Private double. We need what? Width and length, right? Private double width and private double length. Does that make sense, ya banat? Do you need anything else for the... Okay, excellent. So now this is our height. Let us now create a constructor. Okay, source, generate constructor using field. I need all of them. Okay, let's do what now? Setters and getters for your own attributes, right? Excellent. So source here generates setters and getters for all of them, straightforward attributes. Okay, no validation in this example. Now I need to implement what? Add what? Okay, you have two choices. What are they? Look at them now. La 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 la. Now you have two choices. You either implement or make it what? Or make this class what? That's your choice. Okay. You implement all of them, all the ones. If you want, if this is abstract, okay, fine. But now I will add what? على طول. How many I get? Get area, get perimeter, and get what? ماشي الحال. So let's start with the simplest one. What to do here? And you see all of them, what you see? Override, right? Type, wait. Let us do something here. This dot what? Get width times what? This dot get what? Length. Tamam. What is the name? Rectangle, right? Okay. طيب, what else here? Perimeter. Okay, let's do perimeter. What we gonna do with perimeter? It is 2 times, right? It is 2 times this dot get, sorry. This dot get width, length plus the 2 times, right? Okay, plus 2 times this dot get length. Any question on this? What? Where? Yeah, oh, you don't have to put this. It's optional here, tamam? Yeah. If it's, in the scope, yeah. Yeah, you can, in the same class, no problem, okay? But we are programmers, we are lazy. We always try to just use this because when you type this, we get all the options, tamam? Okay, there is a video on YouTube on this constructor. You can see the choices, and I mentioned programmers are lazy. There are cases you must use it, like the constructor, but there are cases that it's optional and only if you are lazy. Go ahead now. Which one? Get length and get width. Right, thank you. So now, is it right now? Did we implement all of them? Can we go and cheat something from the circle? Okay, what I'm gonna cheat? Okay, I'm gonna override what now? To string. What do I need to add to that string? Width and length, right? Is it? So, do you see that? In this class, we only add the new things that belong to our class. And we have shared so many codes and things. Width, which is what? This dot get width, right? Okay. Plus what? ايش بدنا نقول له? Plus what? Length. تمام. Okay. Okay. And finally plus this dot get length. تمام. So now what we need to do, I think we need to reorder the code here. Format, source, format. I think now the code looks fine. So now we have 3 subclasses of 2D shape. They are all 2D shapes and they are all subclasses. So I will just try to make a tester quickly for only this class with the main method. I will call it tester, only for 2D classes. تمام يا بنات? Does that make sense? I'll copy the code to save few minutes since we are, okay, where is the tester here? Do you see it? Where is it? Which one? Shape tester, yeah. I'll just copy some values from here. Tamam? Okay. All of them are 2D actually. Is it? All of them are 2D, right? Here we have cube, right? So I'll take only, okay, I prepared this code before the, so now where is the 2D tester here? 2 tester. So let's create something here. We are on the same package. We have one square and one what? Okay, let's format the code. What else we can create, ya banat? What else? Rectangle, tamam. So rectangle R1 equals a new rectangle. Okay, and it takes 2 sides, right? Tamam? Good? Is this fine? Can you print all of them? Yes, huh? Let us see. When you print a square, you know what's going to happen, sah? Print is good sometimes for testing. Why? Because in the toString, you call all the methods, right? So it will tell you that your methods are working or not. Tamam. So rectangle here, let us just correct this and let me print all of them. I will print the square and I will print also the circle and the rectangle. Does that make sense, ya banat? Okay, let us see. Hopefully our output looks good. And I believe it looks good, right? See, shape, square, area. So far, all these are inherited from where? 2D and shape. And now toString, it was inherited from all of them, but we added what here? The side for a square, in the toString of a square, right? Same thing you see here. Does that make sense, ya banat? Okay, طيب. What about cube now? What about 3D shape? Look at 3D shape now, ya banat. Okay, look at 3D shape. Extends what? And now, what's the new thing in it? Get volume, صح? And the toString, is it overridden? What do we add to it? That's صح? What did we add in the 2D shape toString? Perimeter, right? Okay, now a cube. I believe you all know what a cube is going to be, صح? We're going to have the area and what? Volume. And you definitely know that I don't know how to do that, صح? You're going to Google it or calculate it, right? Tamam. Anyway, cube is simple, huh? Here's a cube. Look at it. Extends what? 3D shape. What else? Then you have what? Which methods in it? No. We have a side for a cube. Tamam? And this is our attribute, right? Now, which methods? Get volume inherited from where, ya banat? 2D shape, 3D shape, right? What about get name and get area? Do you agree with these methods here, implementation? Okay, return math power side cube. Does that make sense? Okay, good. So now, do you have a 3D shape also here? صح ولا لا, right? And it what's the new thing now here? Get volume. طيب. Cylinder, do you know how to calculate the volume of a cylinder? If you don't, I know. I Googled it before the class. But now, is it a 3D shape cylinder? Okay, so what we need for the cylinder? 2 things, right? The radius and height, صح? And then we can implement the get area and get volume and toString, right? And get, okay, there is no get perimeter right here. So let us see cylinder here, ya banat. Look at it. Extends 3D shape. Any question now? What are the attributes? Radius and what? Okay, any question on the constructor? That's it. Set radius, get radius, and get height, set height. Any question? Now you know what I'm doing now. And these 3 methods, starting at line 23, get volume inherited from 3D shape, right? Implemented here. The volume of a cube is different from the volume of a cylinder, from the volume of a prism, from the volume, or I believe they have given you such a thing in your first lab assignment, right? Tamam. Okay. So get area. Is it clear now? Can I add any other 3 shape now, 3D shape with minimum code? صح ولا لا, right? Which way? How many methods I need to implement? Only the difference. Only the difference, صح? Okay, get volume. Get name is nothing, صح? Okay, what else? Get area. Yani this must be done in the class itself, right? This must be done in the class. So let's go to the tester, the old tester here. Shape tester. You see it, ya banat. What do we have here? And here. Then. طيب are they all shapes؟ صح تمام. اوكي بس I wanted. طيب are they all shapes؟ بس see here the array is an array of shapes. According to the laws of polymorphism, if you can create a new circle and a new rectangle and new, but if they are in an array of shapes, you can only call the methods that are common in which layer? In the shapes layer. Does that make sense? Here, they are all considered what? In line 14, they are all considered what? Shapes. You can create a new cylinder, a new area, a new circle, new rectangle. Tamam? But if you go to line 19, for what you say? Shape S. طيب. Don't worry about the code you see in line 21. For S, which methods are available in the shape class? Area and name and toString maybe, صح? Do you have get perimeter in shape? Do you have get volume? Then which methods can be called here only? صح? If you create a 2D shape array, you can call the 3 methods in the 2D shape array. طيب, now you are asking me, what if I want something relevant to the circle, like radius? صح? It's only available where? In the circle. What if I want something like cylinder? I want the height of a cylinder. Height and radius are only available where? In the cylinder, right? In this case, if you are asking or looking for something that is class specific, that's not common in the hierarchy, you need to do what, ya banat? You need no casting. What is casting? And before you do casting, wait. What is inside the shape? Could be what, ya banat? Tell me here, based on this example. Could be circle or what? Rectangle or a cube or a cylinder. Here in this example, we only have 4 choices, right? Right. If you don't do any casting, which 2 methods you can call? Get area and get name. طيب. But if you want, without making mistakes or without your program terminates abruptly, you can check. Sometimes you want to do something if it's only a circle. If S is what? Is S instance of circle here? For example, first one, in line 8, look at it. Is it? Oh, here will be true. But if you try to do what you see in line 22 here, without checking, it will do it for everyone. And when you try to cast a dinosaur as a circle, you will get class cast exception and maybe your program terminates. So to be in the safe side, before you do the casting, you do what? Ask this question, which is what? If S is instance of what? If it is, then you still have to do one thing, which is what? Circle T2 is equal to what? Now you can use it as what? You see, T2 to get what? Radius. But if you don't cast it as a circle, it is still a shape. Only the methods that are in the shape can be used for all objects. Look at for this one. See, ya banat? Yani you still can see I provided 2 things. One here in this example, if it's instance of what? But the second one, if it's an instance of what? Because I know all 3D shapes have what? Get what? Get volume. Did you get this? Yani I'm casting it with a concrete class, but here this is abstract. Huh? I'm not instantiating it. Yani I can cast it, but I cannot say new 3D objects. Huh? So if you cast the shape into 3D shape, can you call the get volume? Right? If it's a cube and you want something from the cube, then you must cast it as what? If you want something from all 2D shapes, what are you gonna do? If you want the perimeter, huh? So what you would say here? If S instance of what? Cast it and then call get perimeter. Does that make sense? Or you can create an array of 2D shapes. That's this way you're going to create an array of 2D shapes, array of 3D shapes, and maybe you 4D shapes بعرفت إذا في 4D shapes huh? Does that make sense? طيب okay then is this if statement gonna make your code? You don't have to touch your code now. You can add any subclass or grandchild, is this word right? Grandchild of a shape. And here if you're gonna do something that is class specific, you use what? Instance up, and then you do what? You do the casting, the one you see at line what? Line 22. And I showed you two different types of casting. Casting from a concrete class like circle, and casting with a abstract class. Go ahead. Oh, it is, but here when you create it as new what here? What did you say here in line 8? New what? خلاص, then it's an instance of circle. It is a shape, but the object is an instance of which class? When you say the new what? That's it. Then it's an instance of what? طيب, S1 is what? Is it a shape? But it's an instance. It is a shape by inheritance, بالوراثة, huh? But actually it's an instance of which concrete class? Does that make sense now? Here, we have all shapes in the array, صح? For shape S, this is what you call this loop يا بنات? Enhanced for loop, تمام? For shape S in the array shapes. So now S, you can print S without anything here. Let me run this and show you. Okay, here get volume, you know from where I called it, right? If you don't want all this code, for example, here, sorry, okay, let me just do this thing here now. I can just show you what? I can show you sys out. And this is maybe enough in many cases. Here, look at this, ya banat. This what? Sys out S. Which toString method will be called? In the instance. No, in the instance. If S is a subclass of a square, then if X is a square, instance of a square, then toString of which one will be called? Is toString overridden? Is toString overridden in the, so when they go and see which one to call, is it the toString of shape, or toString of 2D shape, or toString of square? Which one? The square, the one, because this is an instance of what? And for a circle, they call it from where? Because is it found in the child? Then they will call the one where? In the child. If it's not overridden, then they call the one in the first parent. If it's overridden in 2D shape, but not in circle, then they will call the one in where? In 2D shape. If it's not overridden in 2D shape and not overridden in circle, then we call the one in the shape up top in the hierarchy. Go ahead. It is shape. Maybe you are not familiar with this loop, right? Okay. This is for I is equal to 0, I is less than shapes dot length I plus plus. Okay, but this is called enhanced for loop. It's available in those videos online, and definitely it's covered in so many places. Is this good, ya banat? Is this example clear? Now, can we add any 2D shape or 3D shape, right? Can we apply this example like we have employees in a company? Can we make the employee abstract? And then let us say full-time employees and part-time employees and make them more, maybe what? Abstract. Then we have salary employees, which is a subclass of two of them, right? Then salary, and we have sometimes salary plus commission employees, right? And sometimes we have whatever. And for part-time, we have seasonal employees. They work on seasons, or or hourly wages employees, or whatever, or only by commission. Some employees work, no salary, by commission, and so on. The good thing here, if I have a new subclass of 2D shape, I just need to do what? Just implement it. And I inherit a lot of code from where? And back to the slides. Look at this now. So now what we added, only added what? Rectangle to this one, right? Can you add any 2D shape, ya banat, here? I don't know how many 2D shapes remaining. But now, with the cube, can we add any prism or whatever 3D cube, right? Cone, tamam. What do you need a cone? How long it takes for you to add a cone to this one? 2-3 minutes maybe, right? Mostly gonna implement what? The get volume, صح? You're gonna Google what? The formula, right? To calculate it. And what else? Get name is ready, صح? And get area, this you need to be implemented. So it takes 2-3 minutes. Are they all 3D shapes? Cone and cube and cylinder? Yes. Are they all what? Shapes? Yes. But it depends how you put them. If you put them in an array list of 2D shapes, then you can call which methods? Get volume and get name and get area. But if there are class specific methods, you must do casting. Was the casting clear? If you want to do something or see something that is class specific, then you do from the casting. Any question on the subclasses? Okay, shapes is a famous example. You can do vehicle, ya banat. You know vehicle? Vehicle can be bike, can be wagon, can be truck, can be ATV, can be motorhome, can be many things like this, right? Tamam. So I'll take 10 more minutes. I'll introduce the interfaces, okay? And we will do the remaining part of interfaces on Wednesday at 6:30, which is gonna conclude all the core concepts of object-oriented programming. We started with writing classes, static and non-static things. Then we went to composition, inheritance, and now we talk about abstraction. And today we introduce interfaces in addition to abstraction, but actually it takes less time than abstraction, because if you understand abstraction, then you understand what? Interface. What's the difference, main difference, ya banat, between abstraction and interface? Interface, yani, all the methods are what? But yani, this is not clear true, huh? Up to yani, but this is new, yani. In the last few years, you are allowed to make default methods in abstract. But let us assume no, huh? At least with the book, huh? So that's it, خلاص. There is one more major difference between them. Abstraction, ya banat. The classes we worked with, were they related in inheritance? They were شبه بعض, right? تمام? But in interfaces, no. They don't have to be. They don't have to be related in an inheritance. طيب, I'll ask you a few questions and you answer them. Can you rent a car? Can you rent a home? Can you rent a book? Can you rent equipment? Yes. Are they related in inheritance? Are they all rentable? Can you resize a triangle? Can you resize a table? Can you resize a home? Make it bigger or smaller? Are they related in inheritance? Are they all resizable? طيب, كويس. So, major two differences between interfaces and abstract classes. Abstract classes, usually, there are a lot of similarities. And we leave the differences to the concrete classes at the bottom, right? With interfaces, they don't have to be. Do you pay your employee? ولا ما بتدفعي? You pay them, صح? طيب, do you pay your bills? Then employees can be paid, bill can be also paid, right? They are both, we call them payable, but they are not totally not related in what? Inheritance, right? So look at this. We will come back to this here. This is a payable interface. Look at it. This is an interface, payable, invoice, and what? But you pay an employee and you pay the invoice. Look at the bullets. A finance system has employees and what? Invoices. Employee and invoices are not related by inheritance, but to the company, you must pay both of them, صح? طيب, look at this one here. Look at this code. Very simple code, ya banat. Public interface what? Is what? Double? But usually interfaces don't have many methods. Okay? Usually interfaces do not have. What about this? Look at it. Is it, imagine if payable is an abstract class. Is this method abstract? Look, is there a body? So all the methods of the interface are then. Here, do we say extend or implement? Implement an interface, then you must implement all the methods of the interface, because simply all the methods of the interface are considered abstract. So here, get payment, return whatever salary. Is it difficult? طيب, wait. Let's look at the invoice. Invoice implements what? Implements payable. You can have so much code. But there is one method I need you to implement, which is what? The non-implemented method of the, which is here, bills maybe mahum discount, maybe there are many taxes, maybe there are, and maybe it's very complicated. Here, get payment is only his what? Maybe your classes, you pay them, courses are payable, right? For example, but employee is payable, invoice is payable, and by the way, you can create them in an array of what? But if you create them in an array of payable, you can only call which method? Otherwise, you need to do what? Testing to see the methods that are. Does that make sense? طيب. We'll see more examples. Book, car, porta-cabin, huh? Now, these days, you can rent porta-cabin, right? Are they related by inheritance? Are they all borrowable? خلينا نقول rentable لأنه borrowable مرات بدون فلوس, right? Okay, good. Example 3, animal. All animals make sounds, right? All animals sleep, right? Okay. طيب. We have an interface called what? Animal. That's okay. Both methods are abstract. Yes or no? Is there a body? Now look at the cat. Cat implements what? What you must implement now inside the cat? All the methods of the animal, right? Okay. You have animal sound, and you know how cats do. And with the cat sleep, it makes this sound. Now we have a dog. Must implement all what? This is not the best example in the world, because both are related in inheritance, huh? But it works, right? Okay, it works, right? So now you have a dog, and now both of them, we know both, dog and cat, they have two methods definitely. What are they? Sleep and animal sound, right? So if you see any class that implements the animal interface, then you know there are definitely what? Two methods there. Tamam. Does that make sense? طيب. Here in the main class, my cat, new cat. You can call what? My dog, new dog, and you